Welcome to your first video. So I'm going to give you time to work on other problems. We're going to be going over it the next day in class. So whatever I don't do, I still want you to try to do, and then we'll be talking it tomorrow in class. So first, problem 1, we're going to talk about algebraic expressions with a word phrase. Problem 1A is usually the most difficult. 7 fewer than a number t. A lot of people always want to put 7 subtract t. However, you're taking 7 fewer. You're taking 7 away from. So that means we're going to have our variable t first, and we're taking 7 away from it. So that is what that value would look like. Now for B, it says 2 times the sum. Now right here, these are two different algebraic terms right next to each other. So I have 2 times the sum. That means I should have parentheses because I first have to do the sum before I can do anything else. So 2 times the sum of A and B. So I want you to pause the video and try C and D right now. So yep, pause the video right now and try it. Problem 2, again, you're just writing out the algebraic form. You start with $20 and save. So save means you're adding each week. What would be the model that looks like that? So you start with $20, and you save. Again, you're adding $6 each week. So $6 in each week will, if I put an X there, that means I can plug in however many weeks I'm talking about, and that would be the equation. So that's all you have to do with that. You could put a W, you could put whatever variable you want. Okay, pause the video and do B by yourself. Evaluating. So really all you're doing with this evaluating is you're plugging the numbers in. So I'm going to do 7. If you have a graphing calculator, make sure you put that -4 because it shows a -4. So I'm going to have another parentheses, plus 4, plus 3, and then my B would be 5, and then subtract 8. You can plug this exactly how it is in your calculator. One thing you might notice is that -4 plus 4 will give you 0. 0 times anything is going to give you 0. And then plus 15, subtract 8, so that would give you 7. Again, you can use a graphing calculator if you wanted to do that. And then try B by yourself. So now I'm looking at C. So C would give me 6, and then parentheses, put the 1. You always want to make sure you want to put that parentheses. Minus, put the 1 in parentheses right here. You want to make sure to have these parentheses right here because it could change the outcome of your answer. So if you put that in your calculator, you would get 13 out. That would be my answer. So pause and try D by yourself. Pause and try D. Now if I look at E, just to verify, we're going to be going over the answers for the problems I don't do in class. If I look at E, I'm first going to draw my division bar. I have 2, and then the X I'm going to put in parentheses. Subtract my Y, I'm going to put in parentheses. And then I have the parentheses for everything on top, and then 3 on bottom. When you're putting this in your calculator, you have to either use the division bar, so like the fraction key, and you'll get the right answer, or you'll need to have an extra parentheses around the top. Because when you have a division bar, you're actually doing the top over the bottom. If you put that in your calculator, or I'll solve it by hand, you would get -30 as your answer. So try F by yourself. So this is where knowing your vocab is very important. So I'm looking at this. I have coefficient. Coefficient is the numbers in front of a variable. So if I'm looking at this very first one, this is a term. Anything that's in between adding, subtracting, those are terms. So I have 4 terms here. These are all terms. In this first one, the -4, that's my coefficient. The A and the X, those would be variables because those we don't know what they are, so that's why they're variable. This number all by itself, that would be a constant. There's nothing that's going to change that number because I do not have a variable with it. There's nothing I can multiply. When I'm looking at the problem, now I'm going to focus right here. And I'm looking at like terms. Like terms mean they have to be the exact same. So if I look at this, x squared is going to be the exact same as x squared. Here's y cubed z. So I'm going to underline that one because it's different, y cubed z. As you notice, I made sure to underline the subtraction, or else you can change it to a plus and negative. And then the 2yz, there's nothing in common there. So you can always combine like terms. So my combined like terms, 3 plus 5, looking at my x squared, give me 8. That's an 8, an ugly 8, but still an 8. 8x squared. Now if I look at my 9 and 4, this is kind of like 9 subtract 4, or plus a negative 4 would give me a plus 5y cubed z. And then I didn't have anything with the y, z. So same type of thing when I'm looking at this next problem, looking at like terms. I have x squared, here's another x squared, here's a y, here's a y. So 7 minus 4 would give me 3x squared. And I have 2 plus 3 would give me 5y squared. So I want you to pause the video and try B. Actually, no, I'll do B and then you're going to do C and D. That's what we're going to do. Why? Because this is like a negative 1 in front. So I first have to distribute here and I have to distribute here. So before I do anything with my like terms, I have to combine or distribute. So I have a negative 3k minus m plus 2k plus negative 8m. So now my like terms, here are my k's, here are my m's. So I have a negative 1k and I have a negative 9m, and that would be my final answer there. So I want you to try to see D by yourself, and again, we're going to be going over it tomorrow. And you have a great, grand, wonderful day.